Okay, today we're going to look at 3.1, note, scatter plots, and correlation. So first, let's look at the response variable. So it measures an outcome of a study. It's the y variable. So also the dependent variable, if you think of it in terms of algebra. The explanatory variable is like the independent variable. So it may help explain or influence changes in a response variable. It goes on the x-axis. You can kind of think of that because explanatory has an x in it, so that's one good way to remember that explanatory goes on the x-axis. And then a scatter plot shows the relationship between two quantitative variables measured on the same individuals. All right, so which axis do we always plot the explanatory variable? So the explanatory variable, again, has that x in it, which reminds you that you plotted on the x-axis. The response variable does not have an x in it, so that reminds you that you plotted on the y-axis. How to examine that? So there's three things that you have to remember. A lot of times they'll use the word describe. So you describe a scatter plot by using direction, form, and strength. So direction will be positive or negative. Form will be linear or non-linear. And then strength will be some form of strong or weak. We might say like moderately strong, moderately weak, something like that. All right, and then the second dot is we have to talk about outliers. All right, so now let's talk about positive association. Positive association goes kind of like positive slope. Y increases as x increases. It also goes from the lower left of the graph to the upper right. If you're visual, that might help. And then negative association is basically just the opposite. It goes downhill from left to right. Y decreases as x increases. So it goes from upper left, if you picture a graph, to lower right. All right, does association imply causation? The answer is no. This is a test question. So while the scatter plot may show an association, right, some sort of relationship between these two variables, there may be lurking variables. So that means that we cannot conclude that there is a direct cause. So we have to think about what lurking variables there are that could have possibly contributed to the association. In part 3, or number 3, what type of characteristic of a scatter plot would indicate that there's a strong linear relationship? So the points do not deviate greatly from a line. So they'll appear to be pretty linear. So kind of like we just kind of made some points here. These points appear to be pretty linear, and that would be a strong linear relationship, right? And then number 4, or I guess part 2 of that, is a weak linear association. The points are widely scattered. About a line. So these points might be in some sort of linear fashion, but the points will be all over the place, right? So they won't be as tight as they would if they were going to have a strong correlation. All right. Number 4 says, early on, the most common treatment for breast cancer was removal of the breast. It is now usual to remove only the tumor and nearby lymph nodes, followed by radiation. The change in policy was due to a large medical experiment that compared the 2 treatments. Some breast cancer patients chosen at random were given one or the other treatment. The patients were closely followed to see how long they lived following surgery. What are the explanatory and response variables? Are they categorical or quantitative? So we'll look at the explanatory variables first. So in this case, they are comparing the 2 treatments. So the patients are going to get either treatment 1 or treatment 2. And then the response is the length of life after the treatments. Right? So this one is categorical. This one is quantitative, right? Remember that quantitative has to be a measurement, whereas explanatory in this case is just what type of treatment they had. So that would be categorical. So not something that you can make a scatter plot on because both of them have to be quantitative. All right, number 5. Sarah is concerned about the amount of energy she uses to heat her home. The graph below plots the mean number of cubic feet of gas per day that Sarah used each month against the average temperature that month in degrees Fahrenheit for one heating season. Does the plot show a negative or positive or negative association? So if you look at the graph from left to right, you can see that the points are showing a downhill motion. So that would be a negative association. So part A is negative. Part B, why does this make sense? So if we look at what the graph is talking about, the temperature is increasing on the x-axis. So if the temperature is increasing, you don't need as much heat or as much gas to heat your house. So my answer is as it gets warmer, less heat is needed. Thus, less gas is used. All right, so part B. What is the form of this relationship? So, is it very strong? So the form. Form is talking about, is it linear or not linear? So it appears to be linear. Is it very strong? So you can see that the points are fairly close together, right? There's not a large amount of scattering. So we would say strong. and explain your answer. So I just explained it as I wrote. So linear, it appears to following the path of a line. And is it very strong? There's not a lot of scattering. So that would be your answers. And then part C, explain what the point at the bottom right is. So if we look at that point at the bottom right, it looks like it's about 57, let's say, what about 230? Okay, so what does that represent? So that means that the average temperature was about 57 degrees Fahrenheit, and the amount of gas consumed was about 230, yeah, that might be more. Maybe it's like 290. It seems like it's a lot more than 230. 290 cubic feet. All right, so let's look at number 6. So we're going to plot the points. So let's go ahead and we'll do this one tomorrow in class. So I can show you how to use your calculator again. And we'll go over that at the beginning of class. Same thing with number 7. We'll start class with those 2 problems. And then in case you're going to be gone tomorrow, it's page 158, 1 through 11 odd. And in case you're not in class tomorrow to go over 6 and 7, stop by before school and I can show you how to put that in your calculator. It's really easy. It won't take much time. All right, that's the end of our notes.